Welcome to my channel SPS Physics Classes by S. Panindra Sharma. Today, let us try to deal with some important question in the entrance examination point of view. The first question, how to find out center of mass of the removed portion? So, in the given bigger disk of the radius capital R, a small disk of radius small r is removed such that the center to center distance is nothing but x. Then what is the new center of mass position? Let us try to identify. No doubt that is, in the given problem, we are removing the mass. Therefore, the center of mass x is equals to m1 x1 minus m2 x2 by m1 minus m2 we had to use in the given problem. So m1 means how to find out m1? Mass of the bigger disk is equal to surface mass density sigma. Sigma means what? Let sigma is equal to total mass per area. This is constant quantity. That means mass per unit area. Mass per unit area is always constant quantity. Therefore, m1 is equal to sigma into area of the bigger disk is nothing but r square, and m2 is equal to sigma into pi small r square. Let us take in the given problem. And the location of the first center of mass is at 0, 0, and the second one is located at 0, x, 0 position. Therefore, x, 0 position. Now let us try to substitute these values in the given case. Therefore, the first option however 0 because x1, first one is 0, and m2 is nothing but what you can write down, sigma into pi r square into x by m1 minus m2. That means sigma into pi make common, capital R minus r square we have to do. Therefore, in the given case, minus. So when we try to cancel the like terms, so we can cancel these two terms. Then the final answer is minus r square by r square minus r square into x. This is going to be the correct answer. Therefore, new position given by minus r square by r square minus r square into x, 0, because the shift will be done towards the x-axis. This is the shift length we have to consider in the problem. Right. In the entrance point of view, okay, they will try to ask you some simple questions. So, first case is nothing but case 1. Let us take case 1. Suppose this is the disk what we are imagining here, and this is the portion what it is removed. Means original disk contains radius of r, and the small disk contains radius of how much? This is r by 2, because half of the radius we have. This is called small r, and the distance from center to center, okay, this distance x is equal to again r by 2. So we will try to substitute all these parameters in the given problem, and then for this particular case we can write down as minus of r square by r square minus r square into x value is nothing but capital R by 2. Now upon solving this entire case, substitute here r by 2 whole square divided by r square minus r by 2 whole square into r by 2 we can write down with a minus sign. With a minus sign of so r square by 4 divided by, here you can write down what enough, 3 by 4 r square into r by 2 we can write down. Now however you can write down as this like terms, okay, r square by 4 cancel. Therefore minus r by 6 going to the final answer for that. Consider the next question. Now let us consider the next question in the center of mass. Look at here. Let the linear mass density lambda is equal to a plus bx is applicable for non-homogeneous rod. Then the center of mass is located dash from the starting point. So we will consider there is a rod like this. This particular rod contains a linear mass density variation according to this particular formula. So this is the starting point is L and ending point is L. Let us try to consider a smallest elemental length dx having the mass of dm. Now the mass dm is always equal to lambda into dx we can write down. Therefore, center of mass of this particular system is given by xcym is equal to 1 by, you can write down as integration of Then we can write down as a center of mass position for xcm given by xcm is equal to integration of we can write down as x dm divided by integration of dm. Starting from what are the limits given? 0 to L we had to imagine, because starting where they are asking. For 0 to L, these are the limits, which is given by further. Now in the given case, upon substituting here 0 to L, x is nothing but x only, there is no chance. Dm, what is the value of dm? Lambda into dx. Therefore lambda into dx divided by integration 0 to L lambda into dx. You cannot cancel lambda as a lambda by t as constant, but in the problem it is not constant quantity, it is a variable with respect to position. Therefore lambda is a function, and so you cannot cancel lambda and lambda in the problem. Keep the lambda as it is, and let us try to consider the remaining case. xcom is equal to, now let us try to substitute the value of lambda. So integration 0 to L upon substitution ax plus bx square into dx by integration of 0 to L, you can write down as a plus bx of dx we can write down. Further, upon doing integration you have ax squared by 2 plus here you can write down what? Bx cube by 3 whole divided by, you can write down as ax plus bx square by 2, here running over 0 to L, here also running over 0 to L. Upon substituting upper limit in the problem, okay, you can write down as what? Al square by 2 plus bl cube by 3 divided by Al plus bl square by 2. We can write down like this. Further, upon solving this particular case, we have the answer as a now in this particular case, what we can take LCM, about 6 we got here. So in all cases, one L is common and we can cancel. So one L square and this one L remains, L square remains, here one L is remaining value. Now upon substituting this one, we have AL by 2 plus BL square by 3 whole divided by A plus BL by 2 is the answer. Now upon solving this one, we have what is the final output is nothing but 3 AL plus this 2 comes here, therefore we can write as 2 into BL square whole divided by, so denominator 6 will be there here, into here 2A plus BL whole divided by 2 is there, 2 and this one cancelled by 3 times. Therefore the correct answer for the question is nothing but 3AL plus 2BL square by 3 to the 6 we can write down, therefore 6A plus 3 into 1 means 3 only, 3BL. So at this particular distance exactly, the center of mass of system is located in the given problem. Generally, see, actually I chosen here what some variables like this, but in the examination definitely they will give some numbers. Some A is equal to 1 value, B is equal to 1 value, length from 0 to 1 meter, 0 to 2 meters, like that they will give you in the examination. So you try to substitute those values in this particular case and then get that answer. Okay, all the best.